Today we'll be looking at bearings. Bearings are one of those more practical applications of trigonometry you would actually use in the real world. Bearings are often used when you're piloting boats or planes. You have to aim in a certain direction and go for a certain length of time to actually get to where you want to go. So this is sort of one of those more practical things. Two ways we can look at bearings. We can talk about cardinal directions, so north, east, southwest, like the first example right there. North 30 west, you would start at north, go 30 to the west, okay, and that would tell you what the angle is that goes between the north and your bearing itself. Or you can talk about clockwise from north. North is 0, and as we move clockwise, every time we get to a new cardinal direction, we've gone 90 degrees more, so east, south, and west. Then when we talk about a bearing such as 230, we're actually given a bunch of information. 230 is where the bearing ends up. Because we've gone 50 degrees past south, we could put a 50 in here. Or we haven't gone quite to 270. In fact, we've gone 40 degrees short of it. We could put the 40 in there. And either way, that would help us maybe solve a triangle. In many cases, you'll be using the cosine law because you'll have two objects going in different directions for a certain length of time or a certain distance, and you'll know the angle between them, which is sort of the basic setup for a cosine law question. So if we look at the first example here, we got a sailboat on Lake Huron that's leaving Southampton, setting 20 degrees west of north for 20 kilometers. Okay, so we're going to need ourselves a compass here. So give ourselves a compass, or you could just draw yourself a little grid there. We want to go 20 degrees west of north. So we want to go north, but we want to go to the west of that, so slightly to the left, if you will. Specifically, 20 degrees. And we know they're going to go 20 kilometers. Yeah, assuming Southampton's right here in the center. At the same time, a fishing boat leaving the same place sails 30 degrees west of south. So we're not going south, we're going a little bit to the west of that, right? So we're going to go say the angle in between is 30 degrees. And this boat is going to go for 15 kilometers. It went this way. And we want to know how far apart the boats are at this point. And so the boats are this far apart right here. Now, some people might want to say, well, this looks like a right angle triangle. Just divide that in half and I can solve that. But we don't know it's right angle. Our diagram might be slightly off. Our scale might be slightly off. So we can't say that that is right angled. We just need to solve for x as if it wasn't. But that shouldn't be too bad. It kind of looks like the cosine law question. The only thing I'm missing would be the angle in the middle here. If I could figure out this angle, I would have a perfect cosine law question. This would be A, and this would be little a. So let's see if we can get that angle in the middle. One thing we know about north and south is that they happen to be 180 degrees apart, right? The opposite sides of the circle. And if we know part of this up here is 20 and the bottom part is 30, we can take our idea of north and south being 180 degrees apart, and this angle right here would be 180 minus the 20 minus the 30. It has to be 130 degrees. Okay, well, now it's set up to solve. Okay, cosine law. X squared equals a squared plus b squared minus 2 times a times b times the cosine of that angle we just found. Our angle is 130. Okay, we like this one. Put it all in the calculator just the way it looks. And it should come out to 10.67. Now remember, that's x squared. So to get x, we need to square root that. And if we do, we get 31.79. So word problem, the boats are 31.79 kilometers apart. Okay. Because this is a short lesson, I'm going to do all the examples in one video here, so you don't have to stop and go between them. I will take a look at the second one on the back side. We've got two planes leaving Toronto. It sort of sounds like two boats leaving Southampton, so maybe you want to give this one a try, see if you can set it up and solve it. And then come back to the video and see if you got it right. We're going to start off with Toronto in the middle here. So Toronto. Okay. One plane's going 450 kilometers an hour at 260 degrees. Well, 260 is between 180 and 270, just a little bit less than 270, if you will. In fact, it's 10 degrees less than 270, right? And the other plane is going at 550 kilometers on a course of 320. So 320 would be up here. Okay, and I can figure out that angle. I've gone all the way around to this. That's 320. That's a little bit past 270, right? How many degrees past? Well, that's like 50 degrees past. So I know the angle between them is actually 60 degrees. Uh, one of my planes is going 550. That would be the second one here. One's going 450. That would be the first one. How far apart are they? That kind of looks like the last question we just did. In fact, at this point, it's exactly the same kind of question. So, x squared equals 550 squared plus 450 squared minus 2 times 550 times 450 times the cos of 60. All in our calculator at one time, 257,500. That's x squared. So we square root that, and we'll end up with 507.44 kilometers. I gotta be careful here because the question didn't say how far apart are they. It said how far apart were they after 3 hours. And we haven't dealt with that because we were just at 1 hour. This is 1 hour, right? So to find 3 hours, we gotta take that answer we just figured out there and multiply it by 3. And we'll end up with 1,522.33 after 3 hours. Right, so put our, therefore, the planes are 522.33 kilometers apart after 3 hours. There's example number 2. They really are sort of the same ideas, except for this one used bearings from 0, and the other one used cardinal directions. Okay, the big trick is to get that angle in the middle, right? Third one. Okay, give it a try. See if you can figure it out. Come back to the video. There's no new ideas. We're just approaching them in different ways. Okay, so we've got a ship leaving a port. Okay, going along a straight line of north 25 east. Okay, so I start at north, and I want to go 25 towards the east. So my angle on there would be 25. Yes, and it's going at 8 kilometers an hour. A second ship leaves the same port and travels at 9 kilometers an hour south 45 east. Okay, so south and 45 to the east. Okay, and we were asked if the rate of communication between the two ships has a range of 75. Will they be able to communicate at 6 p.m.? So we need to know how far apart they are, I would say, at 6 p.m. Well, this first ship up here is traveling at 8 kilometers an hour. 8 kilometers an hour for how many hours? If after 12 noon, we want to know 6 p.m., that's 6 hours, right? So they've gone a total of 48 kilometers at that point. The second ship left later. It didn't leave till 2. So it's only been traveling for 4 hours, and it's traveling at a speed of 9 kilometers an hour, so it's gone a total of 36. Okay, so a little bit of problem solving there to get our initial sizes. We still need that angle in the middle. Good news is I know south and north are 180 apart, so I can take my 180 and subtract my 25 and my 45, and I know the angle in between has to be 110. Okay, it's again set up for the cosine law, as most bearing questions are. Okay, so we are going to do x squared equals a squared. That would be the first ship up here at the top, so 48. 48 squared plus 36 squared minus 2 times 48 times 36 times the cos of our angle. The angle is 110. Into our calculator that goes 4,782.03. Remember that's x squared.
Mr. Jones, you have a call on line 801. Mr. Jones, line 801.
So to get x, we're going to need to square root that. Sorry about the interruption there. And x will be 69.1. Okay, so at this point, at 6 p.m., they're 69.1 kilometers apart. The question was, will they be able to communicate at 6 p.m. if their communications has a range of 75? Well, if we're only 69 apart, I think we can communicate. Okay, so yes, the ships will be able to communicate because they are less than 75 kilometers apart. Okay, and that's bearings. For today's homework, you have a sheet. You want to check the answers there. There's sort of all similar types of questions. You have to figure out that middle angle. And don't forget, sometimes if you have cardinal directions, you can also use ideas of 90s in there.